Good morning, students. Yes, we are studying the chapter Gravitation, but this part of the chapter was related last year. So I think we should wait for some time till the CBSE set the syllabus of this year for class 9 science. So let's start a new chapter, that is the work area. Yes, let's talk about the work done. Now we know what is the force. Suppose I am going to push this ball, like this is the ball, and I am going to push it. So, is I am doing some work or not? Now this is the question. And for answering, we should know a few things. First, work can be said that the work is done when we exert some force on a body. It means for work done, there should be some force, because the work done depends on the force. So we can say work done depends on the factor. We are talking about work. So work depends on the two factors. First one, the force. The quantity of force you exert on a body, the quantity of force decides the work done by you. Large the quantity of force, large will be the work done. Suppose, for example, the force, suppose you and your friend both have a weight, like both have some bricks, and your parents told you that you have to bring these bricks to the top of the house, that is on the roof. So both of you are carrying the bricks to the roof. So both of you are doing work because you are exerting the force to bring this bricks to the floor, to the roof of the house. So we can say that the work done depends on the force. The first term on which work is dependent is the force. It's very important that the work should be done in the direction of the force. Suppose we are exerting some force and the work done is in the opposite direction. For example, suppose this is a car and it is moving. Okay, and it's like G. Yes, so it is a G. It is moving with some velocity, and you try to push this G in opposite direction. Then the work done by you is not, you have done a negative work, because the G is moving in this direction and you work in this direction. So it means it's important that if you are exerting the force, then the work done should be in the same direction. We can say the motion of the body should be in the same direction. So the second thing we find that if we exert some force, there should be some movement of the body. And the important thing is the motion should be in the direction of force. So second thing which is important for the work done is motion, or the distance traveled by the body. Distance, or we can say displacement. If we exert some force on a body, there should be some displacement. If there is no displacement in the body, we can't say that the work has been done. For example, if you push this wall, but we can't displace this wall, obviously. So here we exerting some force, but it is there. But there is no displacement of this wall. Since displacement is not there, so we can say work is not done. We did not do any work if we exert the force on this wall, because we are not able to move this wall. We are not able to make a distance, to create a distance by this wall. We can't do it. We can't move this wall to a distance. So it means in this case work done is 0. So two important things for the work done, it should be first the force. Force should be exerted on a body. And second thing is there should be some displacement in the body. If there is no displacement, you can say work done is 0. So in the case of ball, same. Since push this ball like this. We feel tired. Why we get tired? If we don't do any work in pushing this ball, then why we get tired? This is question from my side. You have to answer this question. So the question is why we get tired and we exert the force on the ball though we are not doing any work. So first thing, you will write what are the factors on which the work will depend. Factors on which work done depend. So first one is magnitude of force. How much force are you exerting? It decides your work done. So it is first one is the magnitude of force. If you are exerting more force, your work done will be more. If you are exerting less force, your work done will be less. For example, suppose take the same example as you are bringing the bricks to the roof of the house. Suppose your friend exerting less force. Suppose how it's possible that he exerts less force? Yeah, he has only the one brick and you have two brick. And both of you have to bring this brick to the roof. Then your friend which has only the one brick has to exert less force. And since you have the two bricks, so the force exerted by you on the bricks is large as compared to your friend. Obviously, your friend has only one brick and you have two bricks. So here in the second case where you have the large mass, so the force exerted by you is greater than the force exerted by your friend. It means both of you are doing the same thing, that you are bringing the bricks to the roof of the house. But here in this case, work done by you is greater than your friend. Why? Because the force exerted by you is greater than your friend. So we can say that the work done depends on the magnitude of force. Large the quantity of force, large will be the work done. Second one, displacement. Second one is the displacement. Now we can say the distance moved through the body in the direction of force. It's really important, if you are exerting the force on a body, the motion of the body should be in the direction of the force exerted. Okay? So second one is the distance through which a body moves. Again, it should be, the displacement should be in the direction of the force exerted. So we can say W is equal to force multiplied with the displacement. Work done is directly proportional to the force exerted. I explained you how the work done depends on the force exerted. And the second one is displacement. For one more example, suppose you and your friend both have both of you have only one brick. And suppose you have to travel a very small distance. Suppose you have to travel only 100 meters, and your friend have to travel 1000 meters. Then since your friend have to travel the large distance, so the work done by him will be greater in compared to you, because you travel a small distance as compared to your friend. So it means work done is also depends on the displacement. It's also directly proportional to the distance traveled. So work done is equal to F into S. We can write in the formula of the work done. Work done is equal to force multiplied with the displacement. Okay? So we can also write it like this. Work done will be represented by the symbol W and force by F and the displacement by S. Now, what should be the SI unit of work done? Now, if we go through the formula, according to the formula, W is equal to F into S. What is the SI unit of force? It is Newton. So, okay, I think I should clean board. Yes. So, we know that work done is equal to force multiplied by displacement. So, the SI unit of work done should be force having the SI unit of Newton and the displacement is meter. So, we can say Newton meter should be the SI unit of work done. Work done, this Newton meter we can also represent by joules. So either we write the Newton meter or we can say joule. 1 joule means 1 Newton meter. So we can say the SI unit of work done is equal to joules. This is the SI unit of work done. Now, okay. Now, the work done, okay, is it a scalar or the vector quantity? This is a scalar quantity. So we have to remember this thing that the work done is a scalar quantity. It is a scalar quantity. Work done is a scalar quantity. Now let's talk about what is the work done against the gravity. The same question. I give you one example that suppose you bring 2 bricks to the roof of the house. So here in this case, you have to do some work against the gravity. Since you are moving against the gravity, so you have to do work against the gravity. So how can we find the work done against the gravity? So we are going to draw this part. Work done against gravity. Work done against gravity. So first, what we have discussed? First, what is work? On which factors work depend? That is the force as well as the displacement. What is the SI unit of work done? And is it work a scalar or the vector quantity? Now, work done against the gravity. Suppose you have to move against the gravity. You are going to place this brick having the mass m, and you have to place this brick above the roof of the house. If the height of the roof is h meter, this is h, then what should be the work done by you on this brick? So we know the formula work done is equal to F/S. When you use any formula, you should always write the values, the meaning of these symbols. Like work done is equal to W, force represented by F, and the distance or the displacement represented by S. So, okay. So suppose you bring a brick up to your roof of the house. Since the distance of the roof from the earth is h meter, and the mass of the brick is m. So we can say the force exerted by you. Now we have to go into the Newton's second law. We know that F is equal to m into a. Or if you move something against the gravity, so we can say here acceleration will be equal to the acceleration due to gravity, that is m into g. So we can write down the value of F is equal to m into g, where m is the mass of the brick and g is the acceleration due to gravity. So we are applying the Newton's second law. F is equal to m into a or m into g. Multiply the displacement. How much displacement is done by you on this brick? It is h, since the height of the roof is h. So we can say the work done by you will be mgh. This is the another formula we can use to find out the work done by you on a body of mass m to bring it to the particular height, that is h. If you bring an object to the height h, then the work done by you will be mgh, where m is the mass of the body. Okay? So this is the work done against the gravity. Now, let's do some numerical question because physics is based on theory as well as on numerical. So let's do some numerical which are based on W is equal to F into S and W is equal to M into G into H in case where you done the work against the gravity. You are doing the work against the gravity. So, few simple questions. Let's discuss that. How much work is done by the force of 10 Newton? So, again I am telling you, in physics numerical questions, every sentence has some meaning and you should understand the meaning of the question. Like, how much work is done? So, what is this? First thing is we have to find out the work you have to find out the W. By the force of 10 Newton. What is this? This is the force. We can also find the value what is given, that is it force, it is velocity or acceleration. We can easily find it by seeing the unit of the value. Since it is in Newton, so we can say that it is force, because force have the SI unit of Newton. In moving an object to a distance of 1 meter, again I am reading the question. How much work is done by the force of 10 Newton in moving an object to a distance of 1 meter? So, how much distance you have to move? It is 1 meter in the direction of the force. Again, the important thing is the force and the displacement should have the same value. So, you have to find W, and you know the formula is equal to F into S. F is 10 Newton and S is meter. Again, one important thing is the distance should always be in meter. If it is given in kilometer or either in centimeter, you will convert these values into meter. So, W will be equal to how much? It is equal to 10 joules. So, this is a simple, very simple question. Now, one more question. Calculate the work done in lifting 200 kg of water. So, you can write question by pause this video. Calculate the work done. So, what you have to find? A given work. Work done you have to calculate. In lifting 200 kg of water. Now, the mass of the water is given, it is 200 kg. In lifting means you are doing the work against the gravity. So, if you are doing some work against the gravity, so we can use the value G. Or if it is given in question that the value of G is 10 meter square, then you will use 10 meter per second square. Otherwise, you have to take the value of G, 9.8 meter per second square. Again, I am telling you, if it is given in the question that the value of G is 10 meter per second square, then we use this value. Otherwise, we have to use the value of G, that is 9.8 meter per second square. So, G is, it is given that it is 10 meter per second square. Through a vertical height of 6 meter. Now, you have to move this water up to the height of how much? It was 6 meter. You have to move this water to the height of 6 meter. So, work done, if you are doing the work against the gravity. So, we have to write the formula that W is equal to M into G into H. So, we can use this formula for the values for those questions in which we are lifting something, we are doing the work against the gravity. So, W is equal to mass is 200 into G is 10 and H is 6 meter. So, it will be 6 to 12, 10,000 joules. So, this is the work done by you on this water 200 kg of mass for bringing up to the height of 6 meter. Okay. Few more numerical question. The question is a car weighing 1000 kg. So this is the mass of the car. M is equal to 1000 kg and traveling 30 meter per second stride. So it's not a span, 30 meter per second. So since the car is traveling with the speed of 30 meter per second, it means it is the initial velocity of the car. The speed by which the car is initially moving is called the initial velocity of the car and represented by u. Because how much? It is 30 meter per second. This is u. Stop at a distance of 50 meter. Stop means you have the value of v, it is equal to 0. Since the body is stopped, it means the final velocity of the body is 0. At a distance of 50 meter. So this is the distance traveled by the body as is equal to 50 meter. This is the distance traveled by the body. Decelerating uniformly. It is given that the acceleration is negative. What is the force exerted on it by the brakes and what is the work done by the brake? So first you have to find the force exerted. And according to the Newton's second law, we know that F is equal to M into G or M into A, sorry. Not G, M into A. But in this case, we don't know the value of A. So first what we have to do, we have to find the value of A by using the three equation motion. And we have to choose which equation motion we will use here. So we have the value of U, I told you that all the 4 chapters are based on the first chapter. So if you are not aware about your first chapter, that is motion, you are not able to do any of the numerical question of all the 4 chapters. So acceleration of finding the value of a, we are using the third equation function b square is equal to u square plus 2a to as. So b is how much? It is 0 square is equal to u is 30 square plus 2 into a we have to find and s is 50 meter. So we are going to calculate it. 0 is equal to 900. 0 is equal to 900 plus 5 is a 10. It is 100a. Okay. And then you solve it like you solve the linear equation one variable. So we keep this value to another side. Like acceleration will be 900 upon minus 100, or we can say minus 9 meter per second square. Why is negative? Because here the acceleration is negative, is deceleration. Because the velocity of the body is going to be decreases, and if the velocity of the body decreases, we can say it has retardation. So acceleration we get is 9 meter per second square, and then we can find the f. After it's equal to mass is almost 1000 into acceleration is minus 9. It is minus 9000 Newton. You know what is the meaning of this minus sign in the force? If the force having the negative value, it means the force is exerted in the opposite direction of the motion of the body. Again I am telling you, if the force having the negative value, it means that the force is exerted in the opposite direction of the motion of the body. Since we are applying the brakes, so the body is moving in this direction, and brakes have to apply the opposite force so that it can stop the car. So it means you will write here, you will not write the answer like 9000 Newton. You will write the answer like force is 9000 Newton and negative sign show that the force is exerted in the opposite direction of the motion of the body. So this is the force. And again you have to find W. W is F into S. You know the value of F is 9000. And S is how much? It was 50. After calculation you will get the value 9 5s are 45. 4 5 and 4 0. Joules. Again it is negative. Negative work done means again the displacement of the body is opposite to the direction of force. Suppose you are exerting the force in this direction and the displacement of the body is in opposite direction, you will say the work done will be negative. So again we get the value of W negative sign, having with the negative sign. The value of W have negative sign. It means that the force exerted by the body in the opposite direction of the motion of the body, or we can say the displacement. So these are some questions which are based on the formula of the work done, either against the gravity or the simple work done. Okay, now we will discuss what is the amount of work done if we exert the force with a certain angle. Like suppose you have a toy car. Yeah, I know. Now you don't play with the toy car. But for example, a child is playing with the toy car. He binds this toy car with a thread and he is going to push it. Okay, he is going to push by his hand. So now the work done by the boy, actually the force exerted by the boy is in this direction. He is exerting the force in this direction and the displacement of the body is in this direction. So here in this case the force and the displacement are not having the same direction. It has certain angle. Theta can be any angle. It's not has a particular value. Theta will represent theta for any angle. So, if the force and the displacement of the body having some angle between them, for example, it's theta, then what should be the work done? It's again equal to W is equal to F into S? No, it's not. If we are exerting the force with a certain angle, or we can say, if there is some angle between the force and the displacement, then the formula for finding the work is equal to F into S into cos theta. Now, I know very well, if you don't know about the cos, what is cos here? Actually, cos is a trigonometric ratio, and you will study about the cos in class 10. So, I am giving you a few points which are related with this cos. Okay, I am giving you some values of cos angles, like some angles in cos, like cos 30, cos 0, cos 30, cos 45, cos 60 and cos 90. So I am giving you the values of these angles in cos. Cos 0 having the value 1, cos 90 having the value 0, cos 30 having the value root 3.2 and cos 60 having the value 1.2, cos 45 having the value 1.2. These are value of some angles in cos. So we can learn it. It's not so difficult. We can learn these angles in cos. So for finding the work done, if you are applying the force with a certain angle, then we say that W is equal to F into S into cos theta. So here this theta can be any angle. It can be 0, 30, 45, 60 or 90. Or yeah, the value can be differ from these values, these angles. So by putting the values of these, suppose we have the value cos 30. Suppose the angle between the force and the displacement is 30. Then you will write it cos 30. And what is the value of cos 30? It is root 3.2. Then you can put this value here for finding the work done. So if you are exerting the force with a certain angle, and the angle between the displacement and the work done, the force is theta, then we can say the work done is equal to F into S into cos theta. Now let us discuss the value of cos 180s. Cos 180 and cos 90, both the things I want to explain you. Cos 180 has the value minus 1. What cos 90? What happens if you are exerting the force in upward direction and the displacement of the body is in this direction? Then the angle between the force and the displacement is of 90. Then what should be the work done? We will say that work done is equal to F into S into cos theta. So here the theta is equal to 90. The angle between the force and the displacement is of 90. So we will say F into S into cos 90. And we know the value of 90 cos 90 is equal to 0. So if we put this value here, F into S into 0, we get the answer 0. It means, it's very important, you should understand it, that if you are exerting the force on a body and the displacement and the force having the angle of 90. Suppose you are exerting the force in the perpendicular direction of the motion of the body, then the work done by you will be 0. So okay, I am taking one example. Suppose there is a pulley on the platform. There is a pulley on the platform and he has some load on his head. Okay, lots of load. Okay. He has some load on his head. Now, the force is exerted by the earth in this direction. And suppose the pulley is moving in the forward direction. So, is there any work done by the gravity? No, not at all, because here the force and the displacement having the angle of 90. So, you will see the work done by the gravity of the earth is equal to 0. Since the angle between the displacement and the force is of 90, so we can say the work done by the gravity is equal to 0. and this is the motion of the body. Now you can imagine the body is moving in opposite direction, you are exerting the force in opposite direction. Suppose the case of car. This is a car which having some velocity. This is not the car. Okay. Not this type of G. Now it's car. Yes. Mercedes. Yes. So this is a car and it's moving with some velocity. And now you exert the force in opposite direction. Now you are exerting the force in this direction. And the car is moving in this direction. So here the angle between the force and the displacement is 180. This is the angle 180 degree. So what should be the work done now? Work done is equal to F into S into cos theta. Here theta is equal to 180 degree. And we know that the value of 180 is minus 1. So if we put this value, we get the negative answer. It means the work done is negative. Negative work done means the direction of displacement is opposite to the direction of force exerted on it. Okay. So from this part, we understand the work done can be of three types. Okay, I am going to rub now this part of the board. So work done can be positive, it can be negative, even though it can be zero. So positive work done. Positive work done. What is the meaning of the positive work done? Positive work done means, suppose you are exerting some force on a body and the displacement of the body is also in the same direction. So here in this case, the direction between the force and the displacement are same. It means both having the angle between them is zero. If the force and the displacement are in the same direction, then the angle between them will be zero. And we know that the value of cos 0 is equal to 1. So we can say the work done is equal to F into S. So this is called the positive work done. Positive work done means if we are exerting some force on a body and the displacement is also in the direction of the force, this is called the positive work done. Second one is the negative work done. Negative work done. What is the meaning of negative work done? Negative work done means if you are exerting the force in this direction and the displacement of the body is in the opposite direction, as I explained in this example. You are exerting the force in this direction and the motion of the car in the opposite direction. So here in the case, the work done by you on the car is negative. So we will say negative work done is where the direction of motion of the body is in the where the direction of the motion of the body is opposite to the direction of the force exerted. I explain you in this case, the angle between the force and the displacement is 180 and we know that the value of cos 180 is minus 1. So we can say in this case the work done will be negative. Okay. And the third one is zero. Zero work done. What is the meaning of the zero work done? When there is no work has been done. So we take the example in the initial part of the video. Suppose we are going to push this ball. Now there is no motion in the ball. Since the displacement of the ball is zero, so we can see the work done will also be zero. So in case if the displacement of the body is zero, we will say the work done will be also zero. And one more example. Suppose we are exerting the force and the displacement is also occur. In case if the angle between the force and the displacement is of 90, then the work done is also zero. So there is two cases for the zero work done. First, if the angle between the force and the displacement is 90, we will say the work done will be zero. Or in second case, we can say that if the displacement of the body is zero, we will say there is zero work done. So now in this part of video, we understand that what is work done, what are the factors on which the work done depend, what is the assignment of work done, and is it scalar or electromagnetic? What is the work done? What is the amount of work done? If you exert the force Have a good day.